Cross-Claisen condensation. So like the aldol reaction, Claisen condensation can be done with two different esters, but the compounds must be chosen carefully. Otherwise, you will get a mixture of products, and that's not a good reaction, not useful. So there are ways to do this, and we did talk about this before. So one of them is to choose the reagent so that one of the participants, one of the compounds, is especially reactive or has no alpha hydrogens. Okay, so which one do you think has no alpha hydrogens? This one has no alpha hydrogens. So therefore, this is not analyzable. Oops. It's not. You can't remove this, but it's actually a very reactive. It's very reactive. Since it's kind of like an aldehyde. It's not, it's an ester. Now, or half aldehyde. So this one can form an enolate. Okay, so you remove an H and then you can get a and therefore our product will be at the end. Now, let me mark this so you can see it. This is yellow. This is yellow. This is green. And this is green. Oops, deleted the yellow. Right there. So that's one way, is to choose one that has no high alpha hydrogens on it, and then the reaction can go only in one direction. That's it. You can't have a mixture of products. In B is aldehydes or ketones can also be condensed with esters. If addition to an ester is desired, the ester should be especially reactive. So here's also another aldehyde. Notice here we had both esters. Here we have an aldehyde, and it has no alpha hydrogens. So you can't form an enolate. And it's very electrophilic. And here we have an enolate. This one forms an enolate. And this should say heat, by the way. Not sure why it changed the sign. All right, so very well. So how would the product look like? So the product will, let's begin. So just mark your yellow here. This is where the enolate is going to form, alpha. This is where it's going to attack. Now I'm drawing this in the intermediate because you need to pay attention to a very important point here. So there's an H down here. And then there's CH2. OET. Okay, good. So let's. All right. Now, these electrons cannot come down and kick either one of these groups. You have a benzene ring, a phenyl ring, and you have H. So there are no leaving groups. So what has to be done? What has to be done is it has to be protonated. So you protonate. So you always have to ask yourself, is there a leaving group? There's no leaving group. So therefore, now this can be, since we have heat, so this will undergo dehydration. So we will lose this water, and then the double bond will form there. So it will become like this. And I need you to verify this on your own. Just like that. Now, here's another example. And what I would like you to do is I would like you to pause the video in a few seconds, but let me tell you what I need you to think about before you play the video and maybe work on it so you can test yourself here. So number one, ask yourself when you have this, which one can form an enolate? That's number one. Which of these two compounds can form an enolate? And once you do that, then draw your reaction where the enolate attacks the carbonyl. Now, the next thing that you need to do is ask yourself, are there leaving groups? Are there leaving groups? And then finally, just get to the final product where you form the beta dicarbonyl, or the 1,3-dicarbonyl. So that's what you should be doing. So take a few minutes, work on this, ask yourself these questions, and then play the video of me solving the problem. So you should pause now. Okay. So if you figure this out, I hope you did, but let's actually take a look at this. So of these, which one can form an enolate? It would be this one. It can form either one. So this one forms the enolate. And it doesn't matter which side it forms on. Both equivalent. And this one has no alpha hydrogens. So it can't form an enolate, and therefore this is going to be your electrophile. So therefore, here's our enolate. me just redraw this arrow. Come down here. Yellow, green, here's yellow, and there's green, if it stays. Very well. So now you ask yourself, do I have any leaving groups? Yes, I do. So this is a leaving group. So then you don't protonate, you bring down those electrons, and then this is kicked out. And here's your final product.